Hey, talking about math and history, and we're gonna do an introduction to polynomials. So in this video, we're gonna learn about what polynomials are and what kind of equations those are. So, in the past, we have probably been learning a lot about linear functions. And we've also been learning about nonlinear functions. So basically, when you look at a linear function, there's always going to be a straight line on a graph. So like this, whatever it is, basically, whatever. And when you do that, you're always going to come across f of x as a function is going to equal, for example, 3x plus 7. Or if you like slope-intercept form, y equals mx plus b. You see a lot of this in your younger years of math. And we also probably been hearing about nonlinear graphs or lines. So pretty much these are lines that are never ever straight. These have curves. Sometimes they can be creative and make multiple curves, maybe horizontal curves. And that usually happens when you have a function of x, for example. It's going to have an exponent, or you're going to have y is going to equal x squared. Having an exponent is going to make a curve on a graph. And x squared is one of the most famous equations for making a curved line. So if this was the graph, x squared would look like this. This is the most famous curved equation. So, we probably know what linear and nonlinear lines are, but if you were ever a math geek, or if you really love to learn about math, then if you ever heard this word polynomial, then you'll probably see that when you watch a lot of Khan Academy stuff, or maybe Po Shen Lowell stuff. He's a mathematician that does a lot of quadratic equations that uses polynomial equations, and he also explains how to sometimes expand them, simplify them. But what exactly is a polynomial equation? You've probably seen like x squared plus 5x plus 10. So pretty much normally polynomials would usually be seen with an exponent and a variable. So what we're going to do today is try and find out what the definitions for polynomials is, what is degrees, terms, and names. So what we're going to be doing is trying to find out what these words even mean and what they describe and how we can easily understand what a polynomial is. So let's learn about what degrees are first. So before we learn about these, let's see some example equations. Okay, so here are some example equations. We have equations that are considered polynomials and equations that are not considered polynomials. So, the rules are no square roots, no fractions on exponents, no negative numbers, no variables in the divisor area, and no variables as exponents? So, there's something about these equations that somehow break the rules. Like, for example, 2 to the power of x plus 7 minus 5, that violates no variables as exponents. This one also has fractions as an exponent. That is not allowed either. And we have this one, negative numbers as exponents. That also not applies as well. We should not have that. And for the fourth one, there's a square root symbol, and that definitely breaks the rules. And the last one, we have variables being divided. So that breaks no variables in the divisor area. You can't divide by a variable, or it can never be a polynomial.
Okay, I'm going.
Oh, they're here. Hi. Dad!
Just putting up the house rules.
No dancing, no loud music after 7:30, no touching the root beer cellar.
And the most important one of all, no boys allowed. Isn't it glorious? Sweetie, you accidentally locked the door.
You're not coming back in this house until after my slumber party is over.
Oh, this is mutiny.
What are you gonna do about it?
These ones on the left don't violate the rules. These ones can be polynomials. So, when we understand what polynomials can't have, then we'll be able to learn what degrees, terms, and names are. Let's look at the terms. So, when you look at the terms, you count how many objects an equation has, like x squared plus 4 plus y. What we can see here is there is 1 object, 2 objects, 3 objects. So, the terms actually count how many of whatever you have, or how many numbers you have that you're working with in an equation. Like, here's 1, here's 2, and here's 3. When you count the equations, you're gonna want to have the operator be included with the number, because the operators tell you what to do with that future number, or that number later. Don't be confused what happens when you say 2AB. You might notice that there is 1, 2, 3 objects, but since that 2AB is sticking together, and the math rules state that you can't take things apart unless you divide by a variable like b, 2AB is pronounced as 1, and that also is known as one term. These are called terms. So this can be 3 terms, and the bottom one can also be 1 term. Here's another example of a 1 term. 2x, 1 object on the field. If we look back at the example equations, you might have noticed that 10 is also known as a polynomial. But wait, 10 doesn't have any variables along with it. How could it be a polynomial? But wait, what it does is it cheats through the rules, because going back to the rules, it doesn't violate the specifications. So, here's another example why 10 is a polynomial. If you have 10 on the field, we're going to write 10 here. What we're going to do is write x and 1 right here. So 10x to the power of 1. What we can do is put 1 in for x. And we have 1 to the power of 1. So that is 1. So 10 multiplied by 1 is just 10. So that's why we can say that this is 1 term. So here is another example where just a number would only be 1 term, because there's 1 of something on your piece of paper. That is another example, just like 2x is also 1 term. It's 1 of something. So, the terms actually tell you when you count how many numbers and variables are on the field. Let's learn about the degrees. So when you're looking at degrees, it's a little bit different than just counting how many things there are on your piece of paper. So with degrees, we count as first degree, second degree, third degree, and no degree. So here's an example. We're going to write 10x minus 7 because 10 is my lucky number. This is actually known as a first degree, because if you insert 1 in for x, it's going to equal that number. So just like the previous example, if we put 1 in for x, we get 1. 10, we just get 10. So a first degree happens when you put an exponent as 1. 10 to the power of x. 10 multiplied by x to the power of 1. A second degree equation would look like this. 5x squared plus 2x plus 1. This is called a second degree, because looking at a second degree, you have the exponent as a number 2. And if you put that on a graph, it would look different than a first degree. The second degree has a 2 as an exponent. So can you guess the third degree? What is the third degree? A third degree equation is going to represent like x cubed, or x to the power of 3 is going to be subtracted by 8x. Your exponent is a number 3. That is called a third degree. It is possible to have 0 degree, because going back to that lonely number 10, if you just have a number like 8, for example, that is no degree, because there's no exponent, and 8 is just being by itself. No degree or no exponent is being added to your number. So 8, ta-da! So what degrees mean is going to be your exponent type. What you're putting in your exponents. Now, last, we actually get to name the kind of polynomials. So when naming them, when you learned about first degree, second degree, third degree, and 0 degree, you actually get to name them depending on what kind of exponent you're using. So we can also name them as well. Here's an example. Having equations like 18 as itself, and if we have 5x or 3x squared, that is known as a one term. There is one of something on the field, and that also can be named as a monomial. Mono means one.
We need to meet up with Vitruvius and tell him the piece has been found.
They're up on the monorail. Release the cover choppers.
If you have something that looks like x squared plus x or 5x plus 3, there is 2 terms. There is 2 terms. And that means that there are 2 objects on the field. That will be called binomial or binomial, because bi, by, or bi is 2. If you have equations that look like x squared plus 3x plus 2 and 2x squared minus 6x plus 8, there are 1, 2, 3 objects on the field. That is known as 3 terms. And that is called trinomial. And tri means 3. So these are different ways you can actually name them. And that means when you name them, you're telling and asking how many there are. It's another way of saying terms. So naming them is almost the same thing as counting them, how many there are. And that is the introduction to polynomials and these strange equations. I hope this video has helped you. Thank you for watching Developing Airlines Math Industry. Like and subscribe!